All right, we're working indefinite integrals. Um, okay, this one here, this is secant x, and then you can see there's a parentheses right here, and then a closing parentheses here. So this is secant x times, and in parentheses we have tan x minus secant x, and of course, then we have our dx. All right, so that one's not going to be too bad. This one here, we're going to have to use a trig identity, Pythagorean identity actually, to rewrite this. But this is just tan squared theta plus 1 d theta. All right. So let's go to the board and work this stuff out. So our first one is the integral of secant x, and then I'm just going to put a bracket here so it's clearly defined. We have tan x, tan x, not theta. Sorry, that's an x right there. Minus secant x. Oh my God, why did I do that again? I don't know. I got theta on the mind. I think in the next problem I'll use theta. Alright, dx. So what we're going to need to do is distribute this secant x across. Alright, so I'm going to write equal sign here. So we're going to have secant. Oh no. It's getting kind of ridiculous. Tan x, 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 x. I wanted to write theta. I don't know what's going on with that. Secant of x of x. Times secant of x. There we go. And then I need to close all this in here. And then we have our dx. Alright. So secant x times tan x, right? These are one of those ones you're going to have to remember. Secant x times tan x is just secant x. Right? And minus, now figure out what that is. That's secant squared x. Okay, these two together are secant squared x. And the integral of secant squared x is tan x. Right, tan x. Then of course we got our plus c. My goodness, I'm using theta this time. That's just the way it's going to be. All right, we got the integral of tan squared theta plus 1. And let's put that in parentheses, d theta. So we're going to need to use a Pythagorean identity, and that is that 1 plus tan squared theta is equal to secant squared theta. Right. Okay, so we just want to solve for tan squared theta here, and what we end up getting is tan squared theta is equal to secant squared theta, and then bringing this 1 over to the other side, minus 1. So we're going to do that substitution, secant squared theta minus 1. So we have the integral of secant squared theta minus 1, but then we have this one here, so plus 1 d theta. And we can rewrite this again. This is secant squared theta, right? Because those are going to cancel out, d theta. And of course, this is one that you had to have memorized, and that's going to be tan theta. And don't forget, plus c, right? So the key was to we needed to remember we can't forget our trigonometry. It's very important that this identity right here, forget the identity. All right.